So what are the two main functions? Sine and cosine. Okay. So if I asked you to draw the graph of y equals sine of x, just the base function, would you know what to do? Not yet. Kieran.
It will be a graph that it's a wave graph where the line goes through 0 and it peaks every 90 degrees.
Okay, so if I did 90, 180, 270, 360, okay, and it will go up to 1 and down to -1. So we start at 0, go up, come back down, go down. Okay. So if we sketch this curve, so a sine curve looks something like that. So what are the things we should know? So we should know about sine curves, the amplitude is
1.
1. We should know the period of the function is
360?
360 degrees. Okay.
Wait, why is it 360?
Because it takes one wavelength, takes 360 degrees.
Oh, okay. So
One full wavelength.
Yeah, back.
So where you started from, yeah. Okay. So we looked at how we could change that. So, for instance, if I were to extend the axes and say that it did exactly the same thing but goes up and down to 2 and -2, okay, I still have exactly the same period, which is 360, but what's changed? So the amplitude is 2. So what would be the difference between those two? So that would be sine of x. This one, the bigger one, would be 2 sine x. Okay, so this one would be y is 2 sine x. Okay. If I changed the period, all right, so let's say it goes up and down in half as much time. All right, so peak down, so one wavelength happens in 180. So if I carried on going, so that one would be y equals sine of 2x, yeah. Because that 2, how many times? So the period of that would be 360 divided by 2, being that number. Yeah?
So the period is always 360 over, and then how many full ones fit in the 360?
Yes. Yeah. All right. So what would happen if, well, linking with other stuff you've done. So actually, Kira and I were talking about this earlier, which is how do you know if you have a sine curve or a cosine curve? So for instance, it's not the obvious answer that you're thinking about. So for instance, if I do sine curve, cosine curve, which one?
Can be both.
Can be both. It can be both. All right. So for instance, this one I could represent as y equals what? Okay.
Would that be just it would be y equals sine x plus 2. Cosine
No.
x.
Not quite.
Cosine.
Well, I know it's cosine because you just shift. I'm not sure. I don't don't know if you like shift it, but translated it this to this.
But it's cosine, isn't it? Because it doesn't necessarily, it doesn't start on the centre line, but this one is actually a negative cos of x, assuming that that's 360 and this is 1 and this is negative 1. However, okay, if I were to carry this on like that, yeah, or if I were to carry it on like this, okay, if I were to take a section of it and thinking about things that we've already done, what if I were to start at this point and only consider that? What have I drawn there?
Because the sine period.
That would be what we recognise as the sine curve. However, it doesn't start at this point. So it looks like it could be a sine curve that has been, as you were saying, translated how far?
90.
90. All right? So if I use function notation, how can I say a translation to the right 90? So it'd be f of x minus 90. So I could, instead of doing y equals negative cos, this same curve could actually be y equals sine of x minus 90. Okay? So it could be either or. This and that are exactly the same, give you exactly the same result. Right? So is it a sine or is it a cosine? It doesn't actually matter as long as you get the rest of it right. Now I would say which one's easier, writing negative cos of x or writing sine of x minus 90. Well, it's up to you, whichever one you spot, whichever one you see. All right? Yeah.
Can you draw what a positive y equals cos of x is?
Same thing, but starting up here. So if I
Well, you know, it doesn't.
yeah, she could. So making sure you start at 0 and finish at 360, positive cos of x does it that way around, and negative is the other way.
Is there a tan? There's not a tan. Is there?
We have looked at tan graphs, but it doesn't look like that, does it? It's a different shape completely. So a tangent curve, if you remember, has what we call asymptotes. Do you remember the asymptote stuff?
Yeah.
And the asymptotes lie at, do you remember where they would be and why?
180 and 260.
It's not at 180 actually.
90 and 270?
It's 90 and 270. Do you remember why?
No.
This is a good tester of how you link them together. Okay, so a tan curve will look like this. Okay, and it's got these asymptotes at 90, 270 because what do you know of that normally we deal with sine, cosine and tangent? Trigonometry, which deals with triangles. Okay, so if we look at it, trigonometry only deals in what type of triangles? Right angle triangles. Therefore, if I say tan of theta, what am I talking about theta? But an angle, but also not this one here. So it must be a different angle, yeah? And how do you work out tan of theta? Opposite over adjacent. And which one's this? That's the adjacent. So, if this line here is theta, and this axis here is the tan of theta, this point here would be tan of 90. Right, tan of 90 degrees. And why do I not get a value?
You can't have a tan of 90 degree in
Why?
because the triangle must.
The opposite is the hypotenuse, and you can't decide which one's the adjacent.
Okay, well, do you remember we also looked at this? Do you remember we started looking at special, remember the unit circle? Where that's 1 and that's 1, and if I create a triangle where that's theta, yeah? And do you remember I said that what we would then do is this line could go round the circle to create different triangles, yeah? Remember doing that? So for instance, if I put this one here, right, that would be this angle all the way around. So what were the sides of the triangle? So this side here was the same as, that's the opposite side, so that was sine theta. This side is adjacent, so it's the same as, remember doing this?
Oh yeah, the circle. I think you did make the around.
Yeah. So when we get to 90 degrees, that means that this line here has then gone all the way up there, so there is no triangle. However, tan theta, if you remember, is equal to opposite divided by adjacent, which would be sine theta divided by cosine of theta. And if the angle is 90 degrees, what do you know about either sine or cosine?
Oh, this is a special triangle.
Not sort of, not quite. If the line is straight up, what do you know about this triangle if the line goes straight up? You've already said it once.
Oh, it's 45 degrees in the front?
No. If I've got the line, say ignore.
It's not a proper triangle.
Well, it's not a triangle, but also, which one? So if sine theta is, as we would normally do it, is this height, what's sine theta? Unit circle, so that was 1. But what is cosine theta?
One.
Nope.
0.
0, isn't it? If we get rid of this line, how long is the cosine theta for that?
Oh.
It's 0, right? So what is 1 divided by 0?
0. Or undefined.
Undefined. You can't do it, which is why there's an asymptote at that point. Why then can we have sine of 90? What is sine of 90? Nope. 1. What's cosine of 90? 0. So they work, although you would say there's not a triangle, but they do work given this whole situation. But tan of 90 does not exist. Okay? Could you explain why tan of 270 is the next one that doesn't exist? Okay?
Is that when it makes another full rotation?
Nope. Because if you think, there's 0, there's 90. If I go on, where's 270?
It's on 6 o'clock.
There, yeah? So if you think, wherever I put this, look, if I draw the triangle, I have a sine and a cosine triangle, yeah? If I go down here, I have a sine and a cosine. There are only 2 places where the cosine bit that we have to divide by is 0, which is at 90 and 270. They have a cosine of 0.
That's why those be asked.
What is tan when we're at 0 degrees?
Oh, 90.
So sine is
There's no.
0 and cosine is, it's the length of the line, isn't it? So 1. So 0 divided by 1 is,
And Well, no.
0 divided by 1 is
Zero.
0. And if I go all the way around to 180 degrees, again I've got negative 1 divided, or 0 divided by negative 1 is 0. So which is why when we have our graph look, at 0 we have 0, 90 we have nothing, at 180 we have
Zero.
0, at 360 we have 0, and so on. Okay? And that's why, because of what it is. But yes, that then does link in with your unit circle and special triangles are sort of linked with that. So are you happy with what you're saying about the shapes of the curves? Did anyone else have any other different questions that you want to go on? Yeah.
I was having some trouble with the graphing of inequalities.
So the graphing of inequalities relies entirely on can you graph just straight lines. So for instance, if I said to you, can you graph 4x plus y equals 12? You could do that way.
And then just find 12 on the y-axis.
Yeah.
And then you go down 4, and then over 1, and then point there as well, and
So it crosses at 12,
down 4.
down 4 across 1. So your line would roughly be like this, yeah? Okay. So,
Sorry,
no, if you've got a question, go for it.
I was having I haven't figured it out.
The other option was if we say when x equals 0, we would have 4 times 0 plus y has to equal 12, which means y has to equal 12. And then when y is 0, we have 4x plus 0 equals 12, which means x must equal 3. So I've got my points like that. So I've plotted my points. All right? So I can either, what's this form of the equation called?
That's looking at that one.
Nope,
Y in the vertex form.
nope,
Y equals that 4.
nope.
Y equals mx plus b.
No, you're saying exactly the same. That is slope intercept form. That is mx plus c.
Standard form.
This is standard form, isn't it? This is the standard form. So if you're asked to put it in standard form, that's what it means. Now, the question is, if I can draw that line, then how can I show 4x plus y should be less than 12? That's the inequality. Yes.
So the line would be dotted.
Okay, so we should have a dotted line instead. Ooh. Come on. So the line should be dotted because
Because that means that if it does not include the line,
it doesn't include the line, yeah?
and then everything below the line, so so yes, everything below the line should be shaded.
Well, that depends. Whether you shade what you want or shade what you
Yeah.
don't want.
But then you also put the equation with that y.
Well, if I said to you, put an R in the region that you're allowed. So I'm saying that X and Y points. So do you remember we looked at something that, let's pick a point here, and what could a coordinate be?
Negative 5, 3. Or negative 5, 1.
Should we go with 1, negative 5, get it the right way around?
Oh, yes.
Yeah.
Not bad.
So we check, is this a point I'm allowed or is this a point I'm not allowed? So I would put this in and say 4 lots of 1 plus negative 5 should be less than 12. And if it is, that's the region I'm allowed. All right, so I've got 4 minus 5 should be less than 12. So negative 1 should be less than 12. So yes. So this side is the bit I'm happy with. Yeah, that's the bit I'm keeping. So what we did was actually we shaded the bit I don't want. And I would put an R in the region that I'm allowed to keep.
So
Sometimes it says shade the region you want to keep, but you just have to most of the time, because they know that some people do it one way, some do it the other, they always end the question with, put an R, label your region R. Yeah.
So when it's the less than or equals to, it's
Solid
the
line.
solid
Solid line, yeah. Yeah.
And graphing systems of inequalities is just same
More
thing,
than
another
one at
straight-
once, yeah.
Another straight line, and then you just do the same thing, choose a point, and then.
Yeah, so for instance, if I had more than one, like I've got y must be less than 11, and I've got y should be greater than or equal to 2x plus 2, and I should say x is less than 5, I would have 3 different inequalities, and I'd have to draw all of them. So y being 2x plus 2, I would have some line something like that, yeah? That's this one done. Y being less than 11, so I'd have a dotted line probably up here. And x being less than 5, I might have another line here. So if I had to do, so y must be less than 11, so I'm going to shade above it. And I say x must be less than 5, so I shade this side there. And I say y must be greater than 2x plus 2, so I'm going to shade underneath that. So what's the region?
It's not sure, it's like from.
This side here.
As well as the
Pardon?
as well as the oh wait, no.
It's this whole thing.
Oh.
So this is where some people then go, well, we should shade everything up to that point. I haven't given you very good ones because normally there'd be a boundary on all 3 sides. So quite often what you'll end up with is a set that actually look like, so if here's a set of axes, you'll probably end up with a line going like that and a line going like that. Okay, and then one going like this, and normally the region would be somewhere like that, you know, not always. So they can be tricky, you know, they can get you to draw and go, oh, it's going to be that bit, and actually it's this bit over here, you know, so just double check. Yeah.
You can do it with one of the equations being like a parabola, right? Like a quadratic.
Yeah, definitely. So, for instance, if we have, let's say y should be greater than or equal to x plus 3, so that line would be something like this, yeah? And let's say we had then y should be less than or equal to negative x squared plus 10, or that would be something like this, yeah? So then the region would actually be this bit in the middle. That would be your R. So yes, you could do that. But we haven't really worked on those, so I don't think there'll be. Not yet. We need to. Because you would have to then solve for these 2 points. So we would then, I'd ask you to solve negative x squared plus 10 equals x plus 3. And we haven't looked at that yet. But it's another simultaneous equation thing. Yeah.
So there's the one question from Unit 10 is this stuff. It's going to be something like this, right? Right angle, because Unit 10 is right angle triangles.
Yeah, and then the sine, cosine stuff.
Sine, cosine function. So that one question is going to be that.
This?
Well, not
No.
that, but...
No, this is linear
that's
inequalities.
Sorry, never mind. The stuff we were doing earlier.
Yes, the first lot would come into that, wouldn't it?
Okay.
Well, no, is that in Unit 10? Was that? I think more the Unit 10 was the special triangle stuff. So I should be able to get you to solve sine of x is equal to, I don't know, what would I say?
Okay.
root 3 over 2.
Can you draw?
Does that work?
What do you mean solve?
Or what's x? It's always solve. What's x? I don't know. Have I picked the right one then? So that would be then, we know that we've got the two triangles. Now the one we're looking at, I don't know whether I've picked right there, is this one, isn't it? If I said no calculator, so that's 2, this is 1, this angle is 30 and 60, and I know this is root 3.
This is one that isn't one half.
Wait, I thought the top one was 30.
So sine is opposite over hypotenuse. So opposite over hypotenuse.
But hypotenuse is always larger than opposite. Hypotenuse.
But if this is the opposite side and this is the hypotenuse, that's the opposite, and this is like of 30. So I know that x is 30, no?
Shouldn't the 30 be where the 60 is?
True. Well spotted.
Oh yeah.
So it should actually be 60. Have you got a message? Yeah, so special triangles. So there are certain ones that we ought to at least be able to figure out. So the angles are pretty limited. We should know values for which angles.
For the angles,
Yeah.
well, you should know the 60 in the bottom left.
So we've got 30 degrees, 60 degrees, and 45 degrees. They're the ones that we should know. So you should know sine, cosine, and tangent of these three angles, yeah?
9 values.
Without having to use calculators. So just to say, although you've got the use of your calculator for all your exam, anything that involves these particular ones, if you change root 3 into a decimal, and immediately no marks. Okay? You have to be able to do that one with no calculator. Yeah.
Is it better to memorize the triangles instead of memorizing the?
That's my view, yeah.
That's easier.
Because to be honest, as soon as I've drawn them, I remember that that's root 3 and I don't have to work it out, and then I can work out the other. Having to memorize, if you think that each one has 3 options, so there's 9 things to memorize, or you memorize that triangle, and what was the other triangle?
It's 90, 44, 45, 95, and then 1, 1, and 2.
So 1, 1, and
2.
root 2. That's it.
So
And they're 45.
That
Yeah,
was
exactly.
not even like anything you need to memorize it. That was just
Yeah. And if you can't even remember these, where did that come from?
1 squared plus 1 squared. I mean,
Yeah.
yeah, 1 squared plus 1 squared equals.
Excuse me, yeah, use Pythagorean theorem to work out those missing ones. Okay? Any other questions?
No, wait.
No.
We also have tomorrow's class as well. Because the exams is in the first 2 days.
Yes.
Yeah.
If I said to you, you've got a sequence which is 3, 5, 7, 9, 11, and I asked you for the general rule. Yeah?
N plus 2?
No. You gave me the default incorrect answer. Yeah?
Well, I know they're all odd numbers, and I was gonna say it was 2 as well. But that wouldn't, it's less.
You know, Ashley, what were you going to say? 2n plus 1.
Oh, because that 3's the first one.
Yes.
Oh, I thought it was, okay. Yeah. that makes
First
sense.
term, second term, 3. So these are the n's.
So
1,
that's
2, 3.
skipping every.
Oh, no.
Well, no, because it's not picking up anywhere. That it's assuming that's the 3's the first
That's
one.
the first one.
Yeah.
What, by the way, does this remind you of? If I said y equals 2x plus 1,
It would be slippers.
and what is the 2?
That's the slipper.
Oh, so those could be x values on the
So-
graph.
2 being the slope or the gradient is what it goes up by, yeah?
Yeah.
So it goes up by 2. Hence, we look at what it goes up by, plus 2 every time. That is our slope. Yeah. Then we look at, well, there's 2 ways to do it. A lot of people, I've never done it this way, but I do appreciate if you go back to the initial condition of 0, what would it be? It'd be at 1. So there's the plus 1.
Okay.
Oh, that's kind of cool, actually. Could you give us one
I remember doing this in M2. You have to find if you graph lines based on something like that.
more? Mr. Fox,
Yeah.
if in the this investigation part of the exam, if we can't find the pattern, are you allowed to tell us, but we
No,
get graded down?
I won't even be in the room. You just have to do your best. How about this one?
And 13 is the first term.
13's the first term, yeah.
N-3.
It's not n minus 3. It is never going to be the difference n minus or n plus. Never. It's just not.
Negative 3 and
Oh.
plus 16.
It's going down, isn't it? So what's the gradient? It's going down. It's a negative gradient. It's minus 3 every time. So it's minus
Plus-
3n.
that's smart.
If I go to the initial condition would be 16. Right, slightly different because these ones are linear ones. But what if I gave you this?
Ooh!
Oh, I have it.
No, I already, yeah, you went first.
Okay, so I believe is it n squared plus 1?
It would be n squared plus 1.
So the one for the math homework is just n squared.
Is it just those numbers up there?
Yeah, it was.
Then it's
for-
just n squared.
Okay, good. Because I thought that was too easy. I wrote that and I was like, that just seems like I should be writing more. But
What about this one?
N squared?
No,
I
Oh!
have it.
you have it?
Yes.
What?
N plus 1
in
square.
Yeah.
That's not what I was gonna say, but.
Okay. Now, how can you tell the difference between a linear and a quadratic one? Well, what we do is we look at this difference that you've looked at before, and this is plus 5, plus 7, plus 9. And then do you remember looking at the second line of difference? If it's the second line of difference, if it's plus 2, we know we have an n squared. Okay? If we have plus 4, we know we've got 2n squared. If it's plus 6, we know we've got 3n squared, and so on. Okay? Remember doing that before? Okay. Just checking. Let me ask you a question like this. This is one from an IGCSE. That's good recap. Three-meter tall posts. Okay. There is a difference of 10 meters, and there is a cable between the two.
Mm-hmm.
Okay. This point here is, let's say, 2 meters 60 off the floor. All right. And this point here is 50 centimeters from the top. How long is the cable?
And it's a 3-meter pole. Well, can I say how I would solve it?
Go on then.
So if I know it's 10 meters gap, then you can just do whatchamacallit, trigonometry.
Yeah.
Drag the 10 meter up, you get the 90 angle.
So if we do this,
There.
do we have enough information?
Yes,
How long-
because if you know that point right there in the top right is 260, and you know that point in the top left is 50 meters from the top, which is a 3-meter pole, you know that is 250. Therefore, that line on the farthest right is 10 centimeters, right there.
Yeah.
And then now you have enough.
And this would be
And then that's 100 centimeters.
100 centimeters. You sure?
Yeah, because you want to keep everything the same. What?
10 meters. That's
Oh,
1,000 centimeters.
Oh yeah.
So you can see how the mixture of units and things can catch up.
So
So how would you solve it?
And then, bing bada boom. You don't actually need to. You
Pythagoras' theorem. Yeah. Okay. Do you remember? It's a boat, right?
Oh, yeah.
It's a fish. Okay. And do you remember how we kind of need to solve if we go to the fish? So we've got an angle of depression. Okay. And do you remember I also in the test I said how far is the boat from the fish? And a few of you got it wrong because you actually looked at that distance there, and it's not. It's this distance. So we should know. And quite a few people also got the angle of depression wrong, because the angle of depression is actually this one here. So that's the angle of depression. X is the distance for the fish, but we probably would be also given the depth of the fish. Okay, so this one will be solved using trigonometry. And do you remember the other one, such as we have a tower block and you've got one person stood here looking at the top and another person stood different place looking at the top. Angles of elevation, angles of depression, but different triangles. Yeah.
The angle of elevation would be the bottom angle.
So remember, this person's angle of elevation would be this angle, and the angle of depression would be you look straight out and then look down, yeah? So actually, the angle of depression from the top is the same as the angle of elevation from the bottom. Okay? But what a lot of people do is they look at this and think, they draw the triangle and then go, well, that must be the angle of depression.
So,
Which is not.
if you were like happy all the time, would you say you have elevation?
I would say you have an elevated sense of happiness. Elevation means to lift, doesn't it? The Levavi oculus, as they say. Lift your eyes. Yes.
I mean, what
We just weren't responding in the way that you wanted. Any other questions? We get on before Zoe gets on.